I wanted to talk about applications of centripetal force, how centripetal force is applied in some surprising daily appliances. So basically, yeah, 15 minutes. Just give me 5 extra minutes. 11:05. 11:05. So see, we understand what is centripetal force, right? We said that any force that keeps an object in rotational motion is being acted upon by a centripetal force, and that has to be so because without a centripetal force the object will not change its direction, and without a change in direction an object cannot stay on a circular path. So we use the fact that there is a centripetal force that acts on an object in a few ways. Say for example, when you want to, well, there are three things. There is a laboratory centrifuge and a washing machine spin dryer. Which one is more familiar to you people? So I can start with that example. Which one would you say is the more direct example for you? You all know the spin dryer in a washing machine, right? Washing machine. Okay, washing machine will be a simpler example. Okay, so you know that when you wash clothes in a washing machine, most washing machines nowadays, modern washing machines, have what is known as a spin dryer, right? In some washing machines, it's a separate compartment. In most washing machines nowadays, it's the same compartment that does the spin drying. So, ever wondered what spin drying has got to do with centripetal forces and centrifugal forces? Okay. So, what happens is that in a spin dryer, right? And I'm assuming that it's a cylindrical spin dryer. It's almost always so the case. And this is a top loading washing machine, not a front loading one. Front loading ones also work in almost the same way. Okay. So you have the clothes. Okay, piled up like that. I mean, those who have helped in the house with washing, you will know what that this happens in the end. When you spin dry, you see when you look from the top, you see that the clothes have actually got stuck to the sides, right? And there's a kind of a deep hole in the center. You ever wondered why that happens? Okay. So what happens is that the function of a spin dryer is to dry the clothes, correct? What the clothes, when you wash it, absorb the liquid, the water, and retain it, because there are the fibers, like if you can see in this, there are fibers in the cloth, right? The fibers trap the water between them. They are absorbent, so they trap the water between them. And traditionally speaking, after washing, what we do is we wave the cloth. We kind of do this, right, before we dry the cloth. It acts in the same way, except that in the machine, what you can do is now you can take the entire compartment and you can spin it around at pretty high speeds. You would have noticed that most of the time when the spin dryer is working, the lid of the washing machine will have to be kept closed. If you remove the lid, the spin dryer stops working. Okay, and there is a reason for that. The reason is safety, because the spin dryer, it's spinning at very high speeds. It could be doing anything like about 700 to about 1200 rpm, rotations per minute or revolutions per minute. So that's pretty fast. 700 is actually on the lower side. It's probably more like around 1200 rpm. You can, if there is a way for you to look at the specifications of the motor, then you will get an idea of what is the rpm of your spin dryer. Okay. Now, when that happens, when it's spinning around very fast, right? Now the clothes are being pulled inwards, right? There is a centripetal force that they will experience. So I can take this piece of cloth over here, and that piece of cloth is going to experience a centripetal acceleration towards the center. Okay. But at the same time, the containers, the plastic container which is there is also supporting it, right? And because of that support, it's also going to experience a force pushing it against the outer wall. Okay. So do you get this part? That there is a centripetal acceleration on this side, which means that the container is applying a force on it while it is turning, and that's the only way it can keep on a circular path. And if it is applying a force on it inwards, then there is a force with which this is being pressed. The clothes are being pressed to the outer wall. Is that kind of clear? Okay. So there is going to be a centripetal force acting in this direction, and there will be a counter centrifugal force in the opposite direction. So I put this as centrifugal force, and this as the black one as centripetal force. Okay, remember that it's all an and the consequence of those forces are the acceleration. The centrifugal force is fictitious because there is no acceleration in that side. The centripetal force is real because there is an acceleration on this side. So you see that there is a pair here, there is no pair there. So that is why that is considered as a fictitious force. Yeah, so if you are being pulled in a circular path, right, you will, let's say for example, if I put you on a disc, okay, and this is the axis of the disc, right, and I put a pole here, okay, and I ask somebody to hold on to this pole like that, right, and then I start spinning this pole around. Okay, so as the pole starts spinning faster and faster, maybe, just maybe, this person will be hanging around like that. Okay, so if I ask him, are you being pulled inward towards the center, or are you being pushed outward? Right, what would he say? What would this person say? No, what would the person feel? You're saying
He's getting pushed outwards.
yeah, no, but see, from the pole, what he will be experiencing it, there is a pull from the force. Okay, so I'll contradict this with another one. Okay, what if I put a chair, right, and I ask you to sit on this chair while the same thing is happening? Your back will be stuck against the back of the chair, right, as you're being spun around.
Yeah.
Do you get it? So the reason why the back of the chair pushes against you is the same reason why the back of the container pushes against the clothes. Okay, Manya says right. So I suppose she got that. In fact, that push is quite real because I remember once, I don't know if you, Essel World is still around in Mumbai. When I was in school, 9th standard or something like that, vacation, I once went to Essel World and there was one mummy thingy, the mummy ride. And it kind
It's
of
still
started.
there, sir.
It's still there, okay.
Yeah, even the mummy ride.
Even the mummy ride. Anybody who's gone on the mummy ride, I highly recommend it to experience the effect of centripetal force. Okay, it's like there's a kind of an disc. Yeah, there's a kind of disc like this, and then all around the sides of this disc you have these things in which people stand, and then you're kind of tied up to that. I'm just going to show a few people. It's actually very big, and this whole thing is mounted on a kind of apparatus like this. You get the idea? And this thing starts spinning around like this. So first it starts off with it being flat and spinning around, spinning around, spinning around, and then it starts lifting up. That's when it starts getting really scary. And then at one point of time, it's like tilted completely like this. So it's 90 degrees to the ground, right? And it's spinning around. And the funny thing is you're standing there, you're belted, of course, to the back end of the wall. but you can't even lift your hand off the surface. The centripetal force is so high that you experience enormous weight, fictitious force, but it's creating an enormous amount of weight, and that's the whole effect of the container pushing against you, causing you to turn. Okay, so now coming back to our washing machine spin dryer, the straightforward thing is that the clothes which are part of the same fabric and therefore they are connected with each other, okay, that is not going to break up into pieces. But if you, sorry, not break up into pieces, but I'll just come to that. But if you think about the fabric, since I have drawn it in blue color, I'll kind of show it in blue color. Right? And there are these beads of water. Unfortunately, I drew it in blue, so I'll have to show the beads of water in black. Right? The beads of water can only hold on to the cloth as long as the force of their absorption, right, is lesser than the centripetal force. You get what I'm trying to say? So what will happen is the water will then start migrating towards the sides. Okay, the cloth particles, the clothes will kind of occupy whatever space they can, but they will go as far as possible towards the outer edge all around, but the water particles are going to the edge. Now you have to make a small modification to the container. What would that be if you want the clothes to dry up? So I'm asking a question. Exactly. So you have to put holes. So what you do is you'd have tiny holes all over the sides, right? Perforations. And what will happen is the water will then come out through these. The water droplets will come out through these. Okay, so you may ask, well, I don't see the water droplets flowing away. Well, you have to listen to the drain. And this is the inner container, right? There's going to be another outer container over here. Okay, and the water droplets will fall over here, and then there will be an outlet here straight into the drain where all the water will flow down from here and it will flow out from here. Okay, so that's one very common simple application of centripetal force, which gets your clothes pretty dry. I mean, it doesn't completely dry it unless there is also a warmer dryer inside, advanced I mean, expensive washing machines, the likes that some people might have in your homes, they probably even dry it completely. The one I have at home is a simple washing machine, and it kind of dries it pretty well. You put it out in the sun. If there is good sun, then maybe within an hour everything gets dry. Otherwise, if you have wet clothes and you put it out in the sun, in a summer day, it might take a couple of hours or a little bit more to do that. This is a big help, especially in the monsoons for us, because in the monsoons you want because of the moisture that is there in the air, it takes a lot more time to dry things up. So that's one application of centripetal force that I wanted to talk about. So it's almost time for your math class. So I'll stop over here, and we can continue later. Anything anybody wanted to check or ask about? Yeah, I mean, application of physics is as important as physics itself. Well, maybe not, but yeah. As I was looking through the content on the textbook, I realized that this application of centripetal force, I hadn't dealt with in any way. So that's why I wanted to talk about it. It's an important application. This is also used in what is known as a centrifuge, a laboratory centrifuge, which is used to separate immiscible substances. If you have a solid that is mixed in liquid, but the solid particles are so tiny that they actually never settle down at the bottom. So there is no sedimentation process possible. So in such cases, what we do is we put the the contents in a vial, in a test tube. Okay, so these are all the precipitate that will never settle down at the bottom, no matter how long you keep it. And then through an axis, something like this, we spin this around very fast. This can do, maybe 3,500 RPM. And at 3,500 RPM, the particles of the solid become so heavy because of the centrifugal force, centripetal force basically, that they will go in this direction and they will deposit themselves in the sides of the test tube like that. So when you stop the centrifuge, you'll take out the liquid and you'll find that the deposit has settled down in the sides and there is clear liquid on the inside. So that's the way in which actually we separate blood from blood plasma, for example. Salt from a curry, no. I said immiscible solids. So if it dissolves in the solid, then then you have to use some other method like evaporation processes to get the liquid out. So non-miscible solids. Yeah, Anang sent me a mail for that. Normally, salt from, well, if you are asking it in terms of cooking and you added excess salt to the food, just chop a couple of potatoes and put in it. Potatoes do a very good job of absorbing the salt content. Somehow they reduce the saltiness of the food. But as a scientific process, I'm not sure today I can say anything specifically. Okay, so I'll stop here because Perumal sir will be waiting for the class to begin. It's already past 11. So see you guys tomorrow. Some of you I'll meet tomorrow for the reading session.
Sir, is it the same password for the math session?
Yeah. It will be the same password. Yeah, sure. Okay, so see you guys tomorrow for the reading session, and for all the others, I'll see you on Thursday with, I'll get back to you about whether we'll, as of now, we are meeting on Thursday, but I'll also send you some Google Forms to fill in and find out a little bit more about how we can proceed. Okay, then bye everybody.